All right, so to do this, very simple standard derivation of g prime of t. The only difficulties you might find is that there is a chain rule right there. T, C, R. Pretty simple stuff. 90 goes to nothing plus 45. Sorry about that. 45 is a constant, so it remains the same, times the derivative of cosine is negative sine. So just erase that, make it a negative sine. Remember, that's TCR, so the inside will stay the same, over 18. And remember, brought this over here to get us 2t. Now, the next step you're going to want to do is plug in t of, wait, where'd it go? T of 5. See? And you're going to get, using a calculator, I would assume, this number here. If you didn't, then you did it wrong. So I would advise trying again. Now, it asks you to interpret what this answer means. This means that at time t equals 5, the amount of tons of g that are arriving is this value. Its rate is negative. There are 24.588 less tons arriving per hour at point t equals 5, which would imply, by the way, that at a certain point, if we were to keep this value, it hit nothing. It's pretty simple. The points here should be easy to get. Stop. All right, this one is absurdly easy. All they want you to do is find the total amount of unprocessed gravel that arrives at the plant from 0 to 8. We already have the rate, gt. Therefore, integrals of rates, right? The integral of g of t from 0 to 8 equals, and I'll just skip this for you and tell you the answer so you can check on your calculator, 825, that looks bad, 5.5, 5.1. Right, this is the number you should get. Again, you just literally plug this equation. Very simple. Don't do anything stupid. Points, straightforward. You need to write your integrand. If you don't get all the points. So do it. And the second part is the answer. This is going to be the easiest one of all of them. Stop. Okay, so for this problem, it's important. They're asking you is the amount of unprocessed, key word, gravel at the plant increasing or decreasing at t equals 5. We know the rate of tons arriving, unprocessed, is here. We have this equation all ready to go. And you say to yourself, wow, but how much is it processed? Given to you, and processes 100 tons of gravel per hour. So they want to know that at time t equals 5, whether or not it's increasing unprocessed or decreasing due to process. Now, since we know the amount that's being added and we know the amount being subtracted, our equation is going to look like this. It's going to be 90 plus 45 times the cosine of t squared over 18 greater than or less than 100 at 5. And again, you have a calculator, so use it. The number you're going to get once you plug in 5 should be 98.14 blah, 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 blah. Regardless, it is less than 100. Thus, the amount of unprocessed is decreasing, which you will also need to state. Always explain what it means. Okay? Straightforward, and stop. All right, part D. What is the maximum amount of unprocessed gravel at the plant during the workday? Now, to do this problem, the first thing you want to do is create an equation determining just how much was at any given time. We'll call this A of t. A of t is going to equal the original 500 plus 500, where are you? This 500 tons plus the rate of incoming, right? So the integral of 0 to 8, or sorry, 0 to t, you're going to find your right times of, let's say, the g of t minus, by the way, the amount you're losing, the rate of tons being processed, so minus 100, like that. Okay. All right. Now, you are given a calculator, and I would love it if you could just think about what this meant. But first things first, you can and need to, because you're going to get some points for it, consider A prime. You might think to yourself, why? Why do I have to do that? And quite frankly, I can't tell you, because you have a calculator and can just graph this to determine the maximum amount at any given time. But screw it. Sure, why not learn the rate? So, you're going to derive all of this. First thing, constant non-multiplier, so this goes away. So A prime, which I will actually write down here. A prime of t is going to equal nothing, 0, plus the integral, sorry, not the integral, because the derivative of an integral makes a regular thing. You guessed it, unless you didn't. In which case, I suggest trying harder. Minus 100. And if you want to find the point at which this equals nothing, which would be, by the way, the time at which the amount is no longer increasing, set this to 0, solve for t, and you're going to get a number, if you plug it all in, like 4.9234, thereabouts. And you can use this number, or you can just not, quite frankly. You're going to graph this. You graph this whole shaboodle. And once you graph it, you're going to want to look for the point at which it not only stops increasing, but it has hit its maximum, its peak, the highest point on the y-intercept, or y-intercept, the y scale. And once you do this, you should get the number 635.357. And just in case, I don't know, some insanely weird math happened, you should be able to note that it's going to be at this point in time. Again, you can skip this step to get this answer, but to get all the points, you must consider A prime. Now, for any problem, I would advise check for its derivative. And stop. All done. Yay! If you don't understand it, watch it again. Now stop.